We all think voting is pretty simple, right? The person or the idea with the most votes wins. End of story. But what if I told you the math underneath that simple idea is, well, kind of broken? What if, depending on how you vote, you could get a completely different winner from the exact same group of people? Today, we're diving deep into the hidden and often baffling math of democracy.
So that brings us to the big question for today. Is our core principle of majority rules actually flawed? We're about to see how the simple act of counting votes can lead to some seriously strange and totally unexpected outcomes.
Okay, so to really get our heads around this, we first need to talk about two totally different kinds of decisions we make. You've got your private choices, and then you have public choices. Think of it like this. A private choice is you in a supermarket. Your decision to buy an apple is a direct signal. Your money does the talking. It's clean, it's efficient. But a public choice, well, that's the voting booth. That's where we have to somehow take millions of different opinions, wants, and needs and mash them all together into a single collective decision. And that is where things get really complicated.
So when we're faced with that messy problem of making a group decision, what's our go-to solution? It's almost always majority rules. It just feels right, doesn't it? It feels fair, simple, and democratic.
And it makes sense. It is by far the most common way we make decisions together. If more people want option A than option B, A wins. It seems like the very foundation of fairness. But what happens when we just add one more choice to the mix? Let's watch how this simple logic can completely unravel.
All right, let's run a little thought experiment here. Imagine a tiny community with just 3 voters. They're trying to decide on one of 3 new projects for their town. This is where it gets fun.
All right, so check out their preferences. Voter 1 wants Project A the most, then B, then C. Voter 2, their top pick is C, followed by A, then B. And Voter 3 wants B first, then C, then A. See, everyone has a clear, perfectly logical set of preferences. So, who wins?
Okay, round 1. Let's put Project A up against Project B in a head-to-head vote. What does our little democracy decide?
And A takes it, 2-1. Voter 1 picks A over B, and Voter 2 does too. Only Voter 3 goes for B. So for now, A is our champion. Easy enough.
All right, on to the final round. Our winner, A, is now going head-to-head with the last challenger, C. The winner of this should be the town's final undisputed choice, right?
Whoa, and C wins. Look at that. Voter 2 prefers C to A, and so does Voter 3. So C beats A 2-1. It seems like we have our winner. C beat the winner of the first round.
So, it's settled then. C is our winner, right? C beat A, and A beat B. That seems totally logical. But, just to be absolutely sure, let's run one final vote. Just for kicks. And this is where it all goes off the rails. In a direct vote between C and B, B wins. So let's get this straight. A beats B, C beats A, but B beats C. We're stuck. We are in an endless voting cycle with no clear winner. This is the voting paradox, and it reveals something huge. The order you vote in can completely determine the outcome. Whoever controls the agenda controls the result.
So this whole mess brings up a massive question. Is this just some weird glitch in simple majority voting, or is there something fundamentally broken about any voting system we could possibly invent?
Well, that exact question led an economist named Kenneth Arrow to a discovery so profound it won him a Nobel Prize. It's called Arrow's Impossibility Theorem, and honestly, what it says is kind of mind-blowing. A perfectly fair and logical voting system is mathematically impossible. So here's what Arrow did. He laid out 4 super reasonable conditions you'd think any fair system should have. First, no endless cycles like we just saw. Second, no dictators. One person can't just decide for everyone. Third, your choice between coffee and tea shouldn't flip just because someone adds juice to the menu. And fourth, the system has to work no matter what people's preferences are. And here's the bombshell. Arrow proved it's mathematically impossible for any voting system to meet all 4 of these perfectly reasonable conditions at the same time. Not just hard, impossible.
Okay, so if every voting system is fundamentally flawed, you've got to be asking, how does democracy even work? Why aren't our governments just stuck in these paradoxes all the time? Well, it turns out that in the real world, the way our preferences are structured usually saves us. Let's look at a much more typical situation. Instead of 3 totally different options, imagine 5 people are voting on a single issue, like how much to spend on a local park.
Their preferences are all on a single spectrum, from less spending to more.
Now, I want you to zero in on Jim. He wants to spend $1,000. Notice his spot. There are exactly 2 people who want to spend less and 2 people who want to spend more. He's literally the median voter, smack dab in the middle.
And this, right here, is the key. It's called the median voter theorem. In these common, single-issue votes, the median voter's preference will always win. Think about it. Any proposal for less than $1,000 is defeated by Jim and the folks who want more. Any proposal for more is defeated by Jim and the folks who want less. His preference is unbeatable. And that is exactly why political parties so often try to appeal to the center. They're chasing that median voter.
Okay, so the median voter saves us from the paradox and gives us stable outcomes. That's great. But this brings us to one last really critical question. Just because the middle wins, does that mean it's the best or most efficient outcome for society as a whole?
To answer that, let's just take a quick look at income. In pretty much any country, you've got the median income, the person right in the middle, and then you have the average income. And because a few very high earners pull that average way up, for most people, the median income is actually lower than the average.
So why does that gap matter for voting? Well, public projects are often funded by taxes. The median voter with the median income pays their share of the cost. But because their income is lower than the average, their share of the total cost can be less than their share of the total benefit. This can actually lead them to vote for projects where the total cost to everyone is higher than the total benefit, simply because for them, personally, it's a good deal. The middle choice isn't always the most efficient one.
So what's the big takeaway from all this? That messy, sometimes contradictory nature of politics? It isn't always a failure of our leaders. As one analysis of Arrow's theorem puts it, we shouldn't expect a government to act with the same logic as a single rational person. The math just doesn't allow for it. The apparent irrationality we see isn't a bug. In many ways, it's a fundamental feature baked right into the mathematics of democracy itself, which leaves us with a final crucial question. If a perfect system is impossible, what does the best possible system actually look like?